The moment a fraudulent order gets flagged, nobody outside the building ever finds out it happened. No return, no refund fight, no angry email to customer service. The order just quietly stops existing somewhere between checkout and the loading dock, and by the time anyone would even think to ask why, the answer is already buried three systems deep inside a risk engine that no shopper is ever going to see. I spend my time on the infrastructure side of exactly this kind of problem. Proxies, device farms, anti-detect browsers, the tooling that fraud rings and marketers and researchers all reach for when they need a machine to look like a different machine. I've watched both sides of this fight up close. The people building the fingerprinting and the people trying to slip past it. And what strikes me every time is how little either side actually wins outright. It's not a wall, it's a ratchet. And today I want to walk through exactly how a warehouse decides a parcel is fraudulent before it ever ships. Start with the basic shape of the problem. A fraudulent order does not look fraudulent. It's a normal checkout, a normal card number, a shipping address that looks like somebody's actual house. By the time a chargeback lands weeks later, the box is long gone, the goods are resold, and the retailer is out the merchandise plus a fee. So the entire fight happens earlier, in the handful of seconds between the customer clicking place order and the warehouse printing a shipping label, inside a layer of the internet that basically no shopper ever sees or thinks about. At any retailer doing real volume, nobody is manually reviewing orders one by one. That doesn't scale past a few hundred orders a day, let alone the tens of thousands a large retailer processes. Instead, every single order gets run through a fraud scoring engine the moment it's placed, either built in-house by the retailer's own risk team or bought from a vendor that specializes in nothing but this. Names like Sift, Signified, and Riskified come up constantly in this space. And despite competing with each other, they all work on roughly the same principle. Pull in dozens, sometimes hundreds, of signals about the order, the device behind it, and the account placing it, and compress all of that into a single number. That number decides everything downstream. Score low enough and the order ships on autopilot. No human ever looks at it. Score high enough and it gets held for manual review, routed through extra verification like a phone call or a photo ID check, or in a lot of cases just automatically cancelled with a generic email about being unable to fulfill the order. The warehouse floor itself usually isn't deciding anything at all. It's just receiving a flag or a green light that already got decided upstream, often before the payment has even fully cleared. One of the biggest inputs into that score is device fingerprinting. And this is the part of the stack I know from the inside, because it's the same technology that anti-detect tooling exists to fight. Every browser leaks an enormous amount of information about the machine running it. Screen resolution, the exact list of fonts installed, quirks in how the GPU renders a canvas element, time zone, language settings, tiny rendering artifacts in WebGL that vary machine to machine. None of that identifies a person by itself, but stacked together it forms a fingerprint that's stable enough to recognize the same device coming back, even after someone clears cookies, signs up with a new email, and uses a completely different name. This matters because most shipping fraud isn't one bad actor placing one bad order. It's the same operator running the same playbook across dozens, sometimes hundreds of accounts. Stolen card testing, promo code abuse, reshipping schemes, they all tend to reuse the same infrastructure because spinning up a genuinely fresh, clean device environment for every single order is slow and expensive even for people doing this at scale. So fraud teams cluster orders by fingerprint similarity, and when one device or one tight cluster of closely related devices is somehow behind 50 supposedly brand new customers in a week, that cluster gets flagged. This is also exactly why the anti-detect browser market exists at all. Tools built specifically to randomize or spoof those fingerprint attributes so a returning device looks brand new every time. And they do work to a point. But fingerprinting vendors iterate constantly. And here's the part people underestimate. A spoofed fingerprint that's internally inconsistent is often a stronger red flag than no spoofing at all. If the screen resolution doesn't match the claimed device, or the font list doesn't match the claimed operating system, that mismatch itself becomes a signal, sometimes a louder one than just being a normal repeat device would have been. The next layer is network signals, and this is where geography starts telling a story on its own. Shipping fraud almost always involves some mismatch between where an order claims to originate and where the traffic is actually coming from. Risk engines check the IP address against the billing address, the shipping address, and the country that issued the card. A card issued in the United States, a shipping address in the United Kingdom, and the residential IP sitting in neither country. That's a triangle that gets an order automatically held almost every time. No human judgment required. The complicating factor is that proxies and VPNs are used constantly by completely legitimate customers too. People protecting their privacy, employees on a corporate VPN, someone whose home connection happens to route through a content delivery network. So fraud platforms maintain huge IP intelligence databases that classify addresses by type. Known data center ranges get flagged as higher risk automatically. Known VPN exit nodes get flagged too. Residential proxy networks, the kind that route traffic through real consumer devices so the traffic looks like ordinary home internet, are much harder to catch because they genuinely resemble normal traffic. That's exactly why that corner of the proxy market has grown as fast as it has, and why the back and forth between proxy providers and fraud platforms never really settles. A single suspicious order, on its own, usually isn't enough for a system to act on. A cluster of them arriving too fast is a completely different story, and this is where velocity checks come in. These systems watch how quickly related signals repeat across the platform. The same card number tried across several different accounts. The same shipping address receiving packages under 5 different names. The same device fingerprint completing checkout 5 separate times inside a single hour. The same email pattern, sequential Gmail aliases, or a domain that was registered yesterday, showing up across a whole batch of new accounts within minutes of each other. This is the same statistical logic that shows up in bot detection everywhere else. Any single action can look completely human on its own. It's the rate and the pattern across many actions that gives coordination away. Card testing is the textbook example here, where stolen card numbers get validated with small, low-value purchases before being used for something bigger. Picture dozens of small transactions on different cards, all clustering around similar device or network fingerprints, all inside a narrow window of maybe 10 or 15 minutes. That pattern is close to a signature at this point, and most payment processors and fraud platforms have automated triggers built specifically to catch it the moment it starts. Picture what that actually looks like from inside a risk engine's dashboard for a second. 18 small transactions, each one under $5, spread across 18 different card numbers, all arriving within about 6 minutes, all originating from IP addresses that geolocate to the same rough metro area, all hitting checkout with the exact same device fingerprint hash. Any single one of those 18 transactions, taken alone, would sail through without triggering anything. It's a $5 purchase, that's it. It's only when the system looks across all 18 at once, groups them by shared fingerprint and shared IP block, and notices they landed inside a 6-minute window, that the picture flips from ordinary shopping to something that looks a lot like a card testing operation warming up before a bigger purchase gets attempted somewhere else entirely. The shipping address gets scored on its own too, entirely separate from anything happening on the payment side. Freight forwarders and reshipping addresses get flagged through dedicated address databases, and this covers both legitimate forwarding businesses and operations that exist specifically to receive stolen goods and reroute them somewhere else. Vacant lots, PO boxes that don't match the rest of the order's profile, and single addresses receiving an unusual number of orders under different names in a short stretch of time, all of that raises the score on its own, independent of whatever the card or the device looked like. Address verification services, usually just called AVS, catch part of this at the payment layer already, by checking whether the billing address on file actually matches what the card issuer has on record. But AVS is a blunt tool. It only gives you a match or a mismatch. It doesn't hand you a fraud verdict on its own, because plenty of completely legitimate orders ship somewhere different from the billing address. Gifts, workplace deliveries, someone who just moved and hasn't updated their card yet. So AVS is one input feeding the bigger score, never the whole decision by itself. The more sophisticated platforms go one layer deeper and look at behavioral biometrics, which is really just watching how the order was placed, rather than what it says. Mouse movement patterns, typing cadence, how long someone actually lingers on a product page before adding it to a cart, whether a form field got typed character by character or the whole thing got pasted in at once. Real human checkout behavior tends to be irregular in very specific, hard-to-fake ways. Slight pauses, natural drift in cursor movement, small corrections when someone fixes a typo, scripted checkout flows, and even fast manual fraud. Someone rapidly copying stolen card details off a spreadsheet tend to look mechanically smooth or suspiciously fast next to that. This layer exists specifically because the earlier ones can be beaten with enough effort. A device fingerprint can be spoofed. An IP reputation can be laundered through a clean residential proxy. Behavioral signals are much harder to fake convincingly, because faking them means simulating the small, boring inefficiencies of an actual human being sitting at a keyboard, not just presenting the right static attributes to a script. That's a fundamentally different, much harder problem, and it's why this layer tends to sit near the top of the stack for the platforms sophisticated enough to run it. The reason this whole system works as well as it does is that none of it is a single gate. It's a stack of independent signals: device, network, velocity, address, behavior, and each one catches a completely different failure mode. Beating one layer, say routing through a genuinely clean residential proxy, doesn't help at all if the device fingerprint is still recognized from a previous order, or if the shipping address matches a known forwarder in the database, or if the order velocity coming out of that fingerprint cluster is already elevated for other reasons entirely. Fraud teams call this defense in depth for a reason. The goal was never one perfect filter. It's making it expensive and error-prone enough to evade every layer at once that most attempts eventually trip something. None of that makes the system airtight, and nobody serious in this space claims it is. No fraud stack on Earth is undetectable or unbeatable in absolute terms, and this is very much an ongoing back and forth rather than a solved problem. Residential proxy providers keep improving the quality and realism of their IP pools. Fingerprinting vendors keep adding new detection signals to compensate. Fraud rings adjust their velocity patterns to stay just under whatever threshold got them caught last time. Risk platforms retrain their models on the new patterns as soon as they show up. It's the exact same cat and mouse dynamic that shows up everywhere else on this channel. It's just wearing a shipping label this time instead of a login form. What I find genuinely interesting about this particular corner of it is how invisible the whole fight is to the person actually placing the order. Nobody sees the fingerprint being hashed. Nobody sees the IP getting checked against an ASIN database. Nobody sees the velocity counter ticking up somewhere in a risk engine's memory. The entire negotiation happens in maybe a couple hundred milliseconds between clicking place order and the page either confirming the purchase or asking for one more piece of verification. And for the vast overwhelming majority of shoppers, that negotiation resolves instantly, and they never know it happened at all. There is a full write-up of everything I just walked through sitting on hiddeninternet.org. Breakdowns of the same signals, the same layers, laid out for anyone who wants to read it slower or dig into a piece of it further. And that site is basically the whole reason this channel exists in the first place. The hidden systems that quietly run the internet, explained by someone who actually operates them. If that's your thing, subscribe and follow the rabbit hole. Subscribe to see how the machine really works.